Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we are speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind, but now it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet, 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these two forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible. More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. What would happen to us and our planet if it became as big as the sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the sun, about 865,000 miles. Compared to our Earth, the sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the sun. Scenario 1. The Earth becomes as large as the sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the Sun and gets its mass. Now we have two suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having two centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining ex-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our two-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve. and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the sun collects all the dust and adds it to its mass. Now we have a slightly more massive sun and a white dwarf. The time passes, and Grandpa's sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.